Okay, let us now proceed. Moment of a couple. So first, let's try to define what is a couple. So when we're speaking of a couple, this is a pair of equal forces. So we have a pair of equal forces. So this means that the magnitude of the two forces are equal. Of the two forces are equal. And the direction of the two forces are oppositely directed. So we have a pair of equal forces, opposite in direction. And parallel line of action. You try to take note that their lines of action are parallel. So this means to say that the couple will never be a collinear forces. So these are non-collinear. So if you try to take a look in here now, so this is now a couple. So we have the pair of equal forces. So if the magnitude of this is F, then the magnitude of this one is also equal to F. So they are oppositely directed and their lines of action are parallel. So how are we therefore going? Now let us try to consider that the distance or the perpendicular distance between the lines of actions of the two forces is D. So this is 90 degrees and this one in here is 90 degrees. That is the perpendicular distance. And therefore, the moment produced by a couple is equal to the magnitude of the force F multiply this one by the perpendicular distance between their lines of action. Okay, so this is now the perpendicular distance between their lines of action. And your F in here is the magnitude of one of the forces. This is the magnitude of one of the forces composing the couple. Okay, now, so the unit of a couple, so that is force and that is the distance. So it is a unit of a force, multiply this one by a unit of a distance. Now, we have a unique property of a couple. Now, the unique property of a couple is that the moment produced by a couple is constant and independent of any moment center. Any moment center. So, the moment produced by a couple is constant and independent of any moment center. So, this means to say that if you have a couple, you want to get the moment produced by this couple at point A, this is equal to the moment produced by the same couple at point B and at point or any other point. Okay. So let us try to consider this couple in here having a magnitude of F for the two forces. So the distance between the line of actions of the couple is now equal to D. So it's equal to D. Let us try to determine the moment of this couple about point A, about point B, about point C, and about point D. So let us try to consider that the distance between points A and B is equal to, okay, that is small a. And then the distance between point C and D, so let's consider this one as a small b. So that is now B. So that if you try to get moment about point A, so the moment of the couple about point A is now equal to, considering counterclockwise moment. So let's try to consider counterclockwise moment as positive. So the moment of the couple about point A is now equal to, so let's start with the first one in here. So that is F, multiply this one by the moment arm, D plus A. That is equal to D plus A. Now, the second force composing the couple, there's one in here. So, minus F, multiply this one by A. And therefore, this is equal to F, D plus FA minus F multiply this one by A. So, positive and negative cancels out. So, the moment is equal to, the moment produced by this couple about point A is equal to the magnitude of one of the forces comprising or composing the couple, multiply this one by the perpendicular distance between their lines of action. Now, let us try to get moment of the couple about point B. Still, let us try to get counterclockwise moment positive. So, about point B. So, this couple in here, we're going to have moment about point B, and that is F. Multiply this one by D. Now, the second force, this is your second force, which is still equal to F, passes through your moment center, hence, the moment is equal to 0. And therefore, the moment of this couple about point D is still F, multiply this one by D. Now, let us try to get moment of the couple about point C. Still, counterclockwise moment, positive. So, this force in here has no moment again because it passes through point C. So this is now going counterclockwise, the second force. And this is equal to F, and the perpendicular distance between the lines of action is still equal to D. So that is still equal to D. And if you're going to take moment about point D, moment about point D is still consider counterclockwise moment, positive. So this is the first force, which is F. Multiply this one by B, that is going clockwise, and therefore it is minus. And then we have the second force going counterclockwise, that is positive, and this is equal to, and this is equal to F, multiply this one by D plus B. Okay, D plus B. So that is now D plus B. And therefore, your MD in here is equal to minus F times B plus F, multiply this by D, plus F, multiply this one by B. Hence, the moment of the couple about point D is now equal to F, multiply this one by D. So that is the unique property of a couple. The moment produced by a couple is constant and independent of any moment center. Sample problem 1. Determine the moment of the couple shown. So we have 400 newtons acting at point A, and a parallel force acting at point B is also equal to 400 newtons. So we now have a couple. So we are required to determine the moment of this couple and the perpendicular distance between their lines of action. So first, let us try to resolve the components of the couple. So this is making an angle of 35 degrees. So that is 35 degrees with the x-axis. So if you try to have now your fx is now equal to 400 cosine of 35 degrees. And this is equal to 327.661 Newton. And the component in the y direction is now equal to 400. We have sine of 35 degrees, which is equal to 229.431 newtons. Now, so let us try to consider now the components of the couple. So we have the x-axis. So this is the x-axis. This is the y-axis. So it's the origin of the coordinate system. So we have, so the force acting at point A, so we have now here point A is down to the left. So we have the, that is down to the left. Hence, this is your Fy. And that is to the left. And this is now your f of x. This is your fx. Okay, so and that is now your point A. So we have 200 millimeter. Is 200 millimeter. And the other force acting at point B is up to the right. So this is now your point B. So we have your Fy and this is now your Fx, which is now your Fx. Now, let's try to get now moment of the couple. So let's try to get moment about point O. So we now have the moment of the couple about point O, considering counterclockwise moment positive, is now equal to. So let's start with the force at point A. Fy has no moment because it passes through point O. So your Fx is counterclockwise, going counterclockwise. So positive Fx. Now the moment arm is 200 millimeter. So that one is 200 millimeter. Now, the force acting at point B, Fx has no moment about point O because it passes through your moment center. So we have your Fy. So we now have plus counterclockwise moment. Fy, multiply this one by the moment arm. And the moment arm in here is 100 mn. That is equal to 100 mn. And therefore, the moment produced by the couple, your Fx is 327.661 newtons times 200 plus 229.431 newtons, multiply this one by 100. And that is therefore equal to 8847 5.3 Newton millimeter. Or this is equal to, divide this by 1,000. 1,000 mm is 1 meter, and therefore, it will now become 88.4753. 4753 Newton meter. So that is therefore the couple produced by, and that is the moment produced by the couple. Now, since we have a unique property of a couple, so I'm going to apply the unique property of a couple, that the moment produced by a couple is constant and independent of any moment center. Now, supposing I will going to take moment about point B. So if you try to get moment about point B, still counterclockwise moment is positive. So this is equal to. So the force acting at point B has no moment because it passes through point B. So we have your Fx counterclockwise. So that is Fx, multiply this one by 200. And then plus Fy. So we have plus Fy, multiply this by 100. And this is still equal to 327.661, multiply this by 200, plus 229.431, multiply this one by 100. So that is equal to 88475.3 Newton millimeter. Or this is equal to 88 0.4753 Newton meter. Now, similarly, if you will going to get moment about point A, counterclockwise moment positive. So that is still equal to Fx is going counterclockwise. That is Fx, the moment arm is 200. Plus, your Fy is still going counterclockwise. So we have Fy, the moment arm is equal to 100. So this is still equal to 327.661 by 200 plus 229.431 by 100. And that is equal to the same as 88475.3 Newton millimeter, or is equal to 88.4753 Newton meter. Now, let us try to determine the perpendicular distance between their lines of action. So this is therefore the perpendicular distance between their lines of action. So let us try to consider this one as D, and that is 90, and that one is 90 degrees. So if you try to go back to the moment produced by a couple, so this is equal to the product of the magnitude of one of the forces composing the couple, multiply this one by the perpendicular distance between their lines of action. So in this case, so your M, the moment produced by this couple, is equal to F, multiply this one by D. So what is therefore the value of M? So it is 8, so that is the value of M, 88,475.3, that is Newton millimeter, is now equal to F, and the magnitude of one of the forces composing the couple is 400 Newton. Multiply this one by D. Okay, that will cancel out. Hence, the perpendicular distance between their lines of action is now equal to 221. So that is 221.188 millimeter. Problem number 2. 275 Newton parallel forces are applied to a lever shown. So this is now your lever. So we have your lever A, B. Determine the moment of the couple formed by the two forces. So how are we going to determine the moment of the couple formed by the two forces? So first, let us try to use the components of the force using the horizontal and vertical components. So we have your Fx in here is equal to 75 cosine of 20 degrees. So this is now equal to 70.447 newtons. your Fy is equal to 75 sine of 20 degrees, and this is equal to 25.652 newtons. Now, this is now your lever. This is the lever. The length of the lever. So this is your A, and this is now your point B. So this is equal. Okay, so we have the components. So this is 75. So this is in the x-axis. So that is your Fx. So that is up to the Fx. To the right. And this one in here is your Fy. So this is now your Fy. So the other one is at this point. So we have your Fx. This is now your f of x. And this one is now your Fy. This is your Fy. Now, let us try to determine now that I will going to consider, say, I will going to consider this one as point C. So this is now your point C. So if I'm going to get that one in there, so you try. Note that this one in here is now your, so this is your point C, and that one is point B. Now such that if I'm going to this one in here, so we have your point C. Now such that this distance in here is equal to 360 mm. So this is 360 mm. Now this angle in here is 55. So we have a horizontal parallel to this. So we have 55 degrees. I'm going to consider this one as x, and this one in here as now your y. So that if you will going to get cosine of 55 degrees is equal to x all over 360. This is 360. So your x in here is now equal to, we have 206.488 millimeter. So if you try to get sine of 55 degrees, that is y opposite over the hypotenuse, y all over 360, hence your y in here is now equal to so that is 294.895 millimeter. Hence, this one in here, so this distance in here is now equal to y. And this is now equal to, so this is equal to 294.895 mm. 294.895 millimeter. Now, such that this distance in here, so this distance up to point C So this one in here is, so that is, the distance is 206. 06.488 millimeter. Hence, the moment produced by this couple is now equal to, if you try to get moment about point C, so moment about point C, taking counterclockwise moment as positive, is now equal to, so we have the first force composing the couple. So this one, Fx. So itong Fx is going clockwise. So this is now going clockwise about point C. So we have minus Fx. And the moment arm is, that is now 294.895. 294.895. And then, this one is going counterclockwise about point C. So we have positive Fy. The moment arm is this one in here, 206. So that is the moment arm perpendicular distance from the line of action F1 to the moment center C. And this is equal to 206.488. And therefore, the moment produced by the couple is minus 70.447 229.895 plus 25.652. Multiply this one by 206.488. So the moment produced by the couple is now equal to negative 15. So that is negative 15.486. 485 Newton millimeter, or this is equal to negative 15.486 Newton meter. Now, so what does the negative sign in there imply? So we have, therefore, the moment produced by the couple is equal to 15.486 Newton meter, and this is clockwise because we assume counterclockwise moment in here as positive. And if you try to verify the original figure, so this is now your original figure, the couple is going clockwise. So that is the original figure of this problem. So it is 15.486 Newton meter clockwise. Next, using the components of the forces that are normal and tangent to the lever. Okay, so let us try to consider. This is now tangent to the lever. So this is now axis T. So we now have your axis T. And normal is perpendicular to the level. So this is now perpendicular to the level. And that is now the normal axis, or that one is now equal to N. Now, let us try to determine now the components of this force of the couple in your t-axis, which is tangent, and in your n-axis, which is normal. Now, let us try to determine this angle in here, and this angle is now equal to theta. Now, you try to take note that this lever is making an angle of 55 degrees with the horizontal. Hence, the lever such that this angle in here is equal to 55 degrees. And therefore, your theta is now equal to 55 degrees minus 20 degrees. So your theta in here is now equal to 35 degrees. So we're now ready to determine the component of the couple in your t direction and in your n direction, which is the normal. So if you try to get now your Fn, okay, so F normal, the component of the 75 Newton force in the in the axis normal to the lever is now equal to 75 sine of 75 sine of theta, and theta is 35 degrees. You try to take note that the angle theta is included, okay, in the tangent axis. And this one in here is equal to 43.018 newtons. And we now have the component in the axis T, which is tangent to the lever, is equal to 75 cosine of 35 degrees. And this one is now equal to, this is equal to 61.436 newtons. So 61.436 newtons. So let us try to determine. So we are required to determine the moment produced by this couple. So the moment produced by this couple. Now, so the moment produced by this couple is now equal to, so this is therefore the moment produced by this couple. So I will just going to draw this one in here at this point, and this is now, this is the lever. So we now have your lever. So this one in here is now your point A. So the lever in there is at point A. And this is now your point B. Now, so we have the normal force, which is Fn. Okay, so this is now your Fn. So this is now your Fn. So that is your Fn. And we have tangent. So we now have your, okay, Ft. So that is now your Ft. And that is now, we consider this before as point C. So we have your perpendicular is now your Fn. So that is parallel to that. Perpendicular. So we now have Fn. And this is now your F. Okay, so we have your Ft. Okay, and the tangent distance. Now, so if you try to take, now this distances in here again are, okay, so we have this one. And this one. Okay, so it's perpendicular to the lever, these distances. and this is 360 millimeter, and the other one is, we have the other one, and that is equal to 520 mm. So that is 520 mm. Okay, so the moment produced by this couple is therefore equal to, if you try to get moment about point C, again, counterclockwise moment, positive. This is. So your Fn, so that is equal to negative Fn, this going clockwise about point C. Multiply this one by the moment arm, so that is 90 degrees. And that is equal to 360 mm. Your Ft in here has no moment because it passes through point C. Same through with this Fn and with that Ft. So your MC is now equal to, so your MC is now equal to, Fn is 43 minus 43.018 newtons by 360 mm, and this is equal to negative 486.5 Newton millimeter, or this is equal to 15 minus 15.486, okay, Newton meter, or hence the moment produced by the couple is now equal to 15.486 Newton meter. Again, we get a negative 1 in here, hence the moment produced by this couple is a clockwise moment. Okay, next is using the perpendicular distance between the lines of action of the two forces. So we have the couple, 75 newtons and 75 newtons. So I'm just going to consider this point in here as point C, as what we did consider here before. So if I'm going to get now your BC, this is now your 75 newtons, and this one is your 75 newtons. And this is the perpendicular distance between the two forces. So your length BC in here is equal to 360 millimeter. So let us try to get now the perpendicular distance. So again, this is your BC. So the length of BC, this is now, that is your B, and this is now your point C. That is 360 millimeter. Okay, so we have the force in here. So this one in here is, okay, so this is your 75 Newton at that point. So that is your 75 Newton force. So this is now, so at this point, okay, so this is also your 75 Newton. Hence, this is the perpendicular distance between the lines of action. That is 90, and that one is 90, and this is now the distance D. So that this angle in here is equal to theta, and this is now equal to theta. As previously computed before, your theta is now equal to 35 degrees. So this is 55, hence this one in here is 55. Again, 55 minus 20 is 35 degrees. So, if you're going to get sine of theta, which is equal to 35 degrees, is now equal to the opposite, which is d over the hypotenuse, 360. So, the perpendicular distance between the lines of action of the two forces composing the couple is equal to 294.895. 294.895. So this is millimeter. So if you will going to get moment about point C again, okay, so that is counterclockwise moment positive. And this one is equal to negative 75. Multiply this one by D. And what is the value of D? That is equal to 294.895. And this is minus 15,486.485 Newton millimeter. Or that is equal to negative 15.486 Newton meter. Hence, the moment in here is now equal to 15.486 Newton meter. So that is a clockwise couple.